So we do all this, like I said, is to make sure that we have an idea of what our population looks like. And it's the most effective and efficient way to estimate what our population, our true population is, whether it's the proportion or the mean. So first off, we have p hat will estimate our proportion, x bar will estimate our mean, s will represent or estimate our population standard deviation, and then difference between proportions, difference between our mean, and then our mean difference. Okay, so an example of this in terms of sampling distribution is one that we've done before called find the average word length for Beyonce's Crazy in Love, so that we can know if she actually wrote her songs or not. And then if we take a look at the sampling distribution, ideally these are all samples that we can find if we want to make a set of 5 words and find the average of those 5 words. So each dot represents the average word length from a random sample of 5 words from Crazy in Love. So to continue on, what makes good statistics? So there are 2 ways that we can make good statistics. So the first one is that we have no bias. And when it comes to no bias, we have to ensure that our sample is random. So we randomly sampled. And then we make sure that if we're doing an experiment, for example, we are controlling our environment. Secondly, we also want low variability. And low variability just means that all our data is trending towards like a center. They're not too spread out from each other. So in order to get low variability, all we have to do is just get a larger sample size. Okay, so I don't really have any exam tips for today, but let's move on to the next section, which is 5.2. 5.2 just goes over sampling distributions for one population. So it's like one sample. Either with proportions or with means, and just going over all the notations and formulas again. So in our 2 examples, it talks about either a proportion or mean, but our first example is at a large local high school, 52% of the previous year's graduating class enrolled in a 4-year university the following fall. The school counselor contacts a simple random sample of 50 of the previous year's graduate. Find the probability that the simple random sample contains at least 23 students who are enrolled in a 4-year university. So as you can see, there's a picture, and then there's work that we need to show. We're not going to show all the work as we usually do, because a lot of it we're going to do in the table. So I'm going to first start off by figuring out if example number 1 is a proportion or a sample mean. But as you can see, they talk about 52%. So I know that that's what they're claiming. They've also given me a random sample, and it says 23 out of 50. So again, I'm also leaning towards proportion. So first off is to label my parameter, which is the true population proportion. And as you can see that they said that my P is 0.52. My P hat is going to be 23 of the 50. And then to calculate my shape, I'm going to use N times P and N times 1 minus P. So you guys can plug some values in. These are the values that you should put. In terms of my center is the mean of P hat is going to be the same as my claimed proportion, which is 0.52. So I'm going to put mean of P hat equals 0.52. My standard deviation is calculated using P, because we have our population proportion, so we should use that rather than using the sample, which is not as good of an estimate. And then my z-score value, I'm just going to take all these values and throw it into my test statistics. So okay, so from there, I'm going to calculate out some values so that I can do the show work part. In terms of doing work, all you need to do is just show me what the probability you got, because we did most of the work before, and then we're looking for more than negative 0.85. And then I'm going to go into my z-score table and calculate that, but just making sure that I do 1 minus at first. Okay, so the z-score I got for negative 0.85 was 0.1977. In terms of the graph, I am going to put my mean in the middle, which is 0.52. I'm going to shade above 0.46, and then I have to also make sure that I label my graph. All right, so that was part 1. Example 2 is the ACT scores a recent school year were approximately normally distributed with a mean of 21 and a standard deviation of 5.4. If a random sample of 5 test scores is chosen, what is the probability that the sample mean is 25 or greater? So the true population mean here is 21. Sample mean is 25. And then of these 3 conditions, in order to know if something's approximately normal, this one's told me that the population was approximately normal, so I'm going to check that off. And then in terms of our center, our mean again is 21. Our standard deviation, I'm going to take the population standard deviation, which is going to be 5.4, and then divide that by the square root of our sample size, which is 5. And this value comes out to 2.41. And then in terms of the z-score, I'm going to plug in 25 minus 21 over 2.41, which is going to give me 1.66. So in terms of showing work, I'm looking for anything that is 25 or greater. So I'm going to put P of z, or the probability that our z-score is greater than 1.66, is going to be the same as 1 minus 0.9515, which eventually equals to 0.0485. And then I'm going to put 21 in the middle, and I'm shading anything greater than 25, and then labeling my graph. All right. And then exam tip is just to make sure you interpret your values in the FRQ. So what I'm talking about is just make sure that you interpret these values at the end of this problem. So the probability that the simple random sample of at least 23 students who enrolled in a four-year university is approximately 80%. Okay, on to the last, and this one is no work that needs to be shown, but just 2 examples, and we're going to try to fill out what we know. So example 1 says the 2 veteran salespeople at a local company keep track of the proportion of sales they make out of the number of sales meetings they have. Person A made sales at 42% of their meeting. Person B made sales at 30% of their meetings. Their manager independently selects a random sample of 50 meetings for person A and 60 meetings for person B. Describe the sampling distribution of p hat sub 1 minus p hat sub 2. So they told us that this is already 2 proportions. So what we have here is that they gave us our parameter already. So p sub 1 minus p sub 2. Okay. All right, so we obviously have 2 proportions here. So taking a look at the parameter and the statistics, for the parameter, typically they will give us what the value is, and then here they gave us 42% and 30%. So what you want to do to find p sub 1 minus p sub 2 is just subtract 0.42 minus 0.3, and you get some value there. Our p hat sub 1 minus p hat sub 2, we actually don't have enough information for that because they kind of ended it off with like, okay, so we have 50 people and 60 people, and then they didn't give us of those what we know. So if I were to finish this off, I would do set up two fractions, because eventually I just need the numerator to calculate that. In terms of my shape, if I want to know something's approximately normal, the values that I should plug into here is p values, so p sub 1 and then p sub 2's, no p hat values there. In terms of my center, I'm just going to take the population proportions and subtract them, which is going to still be 0.42 minus 0.3. And then for my standard deviation, just notice that I'm using p instead of p hat there as well. Okay, for means, for example 2, it says the weight of a cupcake at a local bakery have a mean of 115 grams and a standard deviation of 8 grams. The weight of donuts at the same bakery have a mean of 28 grams and a standard deviation of 12 grams. Two independent random sample of size 40 are chosen from the cupcakes and donuts. Describe the sampling distribution of x bar sub 1 minus x bar sub 2. So mu sub 1 minus mu sub 2 is the true difference in population mean. So in our scenario, we see that our population mean is, we have 2, which is 115, and the 28. So I'm going to take those and subtract it from each other. And in terms of my sample mean, they didn't give me too much information, so I need more details for that. In terms of our condition, both the sample size were 40. So I'm going to use CLT for the normal distribution. And then here I've already calculated my mean, basically my x bar mean from above. And in terms of the standard deviation, you're just going to plug in values, but just make sure that you do square those values. So these are the values that I should plug in and how it's going to look like. All right, so that's pretty much it for the video. There is no exam tip for this, but just make sure that you use the formula sheet, because that's going to be your best friend, so that you don't get confused on what the formulas are.